hey, Mashara, I have a problem.
Yeah.
What's this bullshit? So this is the TLC plate of my reaction, and this is the starting material to compare it with. This is right before I did the column to purify.
Right side is the product, right? The top one.
Yeah.
Okay.
Why does it look so pure actually here? It's odd. But anyways, so this was 20% ethyl acetate in hexane. So it looks fine. So I said, hey, it's right here. RF is about 0.3. This is good. So we can go up to 20% potentially. Obviously, we're gonna go slowly. So I went 0%, then started climbing 1, 2, then 3%. Here we are at 3%, and it all these impurities are stacking up. And I was wondering, wait, why? But this didn't show that. With up to 20%, this was fine. So yeah, I don't understand what's the discrepancy.
Okay. I can explain. Let's go to the board. Okay, suppose you have this TLC plate. You know already TLC, like thin layer chromatography, right? So thin layer on a glass plate on the silica. So you spotted your compound here and you run the solvent. So like 20% ethyl acetate in hexane, according to you. Okay, so this crude is moving, and suppose your crude was here, okay, and this thing happening against the gravity, okay, against the gravity. But while you're doing in the column, there are a couple of things you need to consider. So this is suppose silica gel, and you loaded your compound here, and with the solvent your compound can move with the gravity.
Yeah.
You understand?
Yeah.
That is called with the gravity. Actually, with the gravity, okay? And that's why it can move faster than this. Always, like it is like it will pull up against the gravity, along with like, not only that, most important thing is the like texture or like formation of the silica. Here the silica is like a two-dimensional, but here the silica is like a three-dimensional, like total round shape.
Yeah.
Okay, so in that case, the solvent thing, compound thing, there is a term called like solvent vortex or something. It will try to show,
Oh,
go
I do
like
remember
through
that.
this.
Ah.
You understand? Like its pathway could be like different, like
It's not just linear.
like not
Yeah.
like linear.
Yeah.
Okay, but here it could be like linear,
Yeah.
and that's why sometimes you can be misguided, like why it is showing like this, and in my column everything is coming up.
Yeah.
First question, you saw in your first TLC while you compared your starting material and the crude, and you say you saw there was no sort like some spot on that.
Yeah.
It could be one reason, like when you do TLC in the like with the crude and starting material, that crude was very diluted, and that's why those were not like visible.
Probably.
Okay.
Yeah.
But while you do with the column, so
Everything is
everything
there.
is
Yeah.
there. In that case, you might see some other additional spot.
Yeah.
Now the solution, like how to
deal with this? Yeah.
deal with this.
Yeah.
You can run with the like 0% hexane. Initially, don't increase like ethyl acetate. Okay.
Yeah.
So in that case, your top spot, which can be, first you have to check with the TLC.
Yeah.
Run with the 0% hexane couple of times before starting column. Couple of times. See like if top spot is moving.
Okay.
If it is, then just wash out those things with the hexane.
Yeah.
Then finally you can increase immediately your, suppose you have like a small spot there.
Yeah.
If those are moving like with the hexane, just wash it out. And after that, once those are done with the TLC tag, then you can increase your polarity to get out this compound.
Yeah.
But another thing also you have to remember, in your compound, what are the functional group there? Is it getting changed with the silica gel? If it is, like why? What kind of precaution you can take. As far I know, like you have the amine type compound, like
Yeah.
NH.
Yeah.
Sometimes with the
Have a
polar
secondary
silica
one, yeah.
gel, that secondary NH could be like problematic, like or like dragging or like
Yeah.
making something else.
Hmm.
So in that case, you can do the two-dimensional TLC before putting in the column. Okay. What is two-dimensional TLC? So make kind of a square shape TLC. Okay. Then put your compound spot here, okay, and then run in the mobile phase like this direction.
Yeah.
First this direction. So suppose your compound move here, okay, and then rotate this silica like
90 degrees.
yes this
Yeah.
way. Now like rotate this way, like
Yeah,
make
yeah.
it this way, and after that run that solvent, okay,
Going that way, yeah.
and then if your compound move again through a straight line, then you can think, okay, my compound is stable in the silica gel.
Yeah.
But if it goes something like this way or that way, or like with like kind of tailing, okay,
Yeah.
that means you can decide, okay, this compound is not stable in the silica, so you shouldn't use silica gel for the column. In that cases, you can take different TLC like alumina TLC. Sometimes
Oh.
sometimes some compound can be purifiable with the alumina because alumina are kind of basic in nature. There are some neutralized alumina also, but mostly alumina is basic, and you have like an H type compound that is also basic that will help to get the purification. So there are many things you have to think before starting column or before starting with the silica thing. So here one of the good point, like to check whether your compound is stable or not stable by doing the 2D TLC. It is called 2D TLC. Okay. So if you see like stable, then you can go with the column, silica gel column, but do initially like all wash out with like less amount ethyl acetate or like zero ethyl acetate, like hexane wash out all the top spot, then increase the polarity. In some cases that is also problematic. If you add like hexane only, in that case sometimes some other impurity can come first.
Oh, it changes it.
Yeah, it changes
Oh.
the things.
Okay.
So suppose with like 2% ethyl acetate, your compound is moving here, and there may be some impurity here, and these impurity can switch. I have seen many times
Oh my god.
with the like only hexane. So you have to like play around before before setting the column. So do the 2D TLC and run the TLC in different composition of the solvent. So what is this? One is 100% hexane, okay?
Yeah.
Then hexane ethyl acetate 1%.
What are you
And-
talking about? This is for TLC?
Yes.
Okay.
Before, like when you are starting the reaction, like 2%, 2% ethyl acetate, hexane in like 5% ethyl acetate, 10% ethyl acetate, and 15% ethyl acetate, and 20% ethyl acetate.
Uh-huh.
And then see the pattern, like how those are looking. I know this
compare
is
them.
very tiresome,
Yeah.
but at least for the first time reaction, when you're doing, you have to study that reaction with the crude, like play around, see like which is giving you the better resolution, okay? And then sometimes with the hexane, you may see like it is not moving actually, but you have to take it out, dry the solvent, and put it back again, the same TLC. So run 3-4 times, like in hexane, see what is the change, like if you see anything moving or not. Even if you see something is just moving, that means it has some tendency to move with the hexane. Then you can start with the hexane. Then do the same thing with the 1%, same thing with the 2%, same thing with the 5%. You can also do like 3-4, but you don't need to. Like 2% after 5%, then do 8% or like 10%, then do 15%, do 20%. And see like run couple of times. At least with the higher percentage, at least run 2-3 times.
Oh, yeah.
And with the lower percentage, at least run 4 or 5 times. Just let the mobile phase to run
keep
on the
going back
TLC
and forth, yeah.
and take it out, dry the
it,
solvent and put it back.
in. Yeah.
First check it, like see
Yeah.
it, okay?
Yeah.
And then you can tell or like you can get idea what is going on, how to do that, okay?
No. How do you? Oh, you were gonna say something.
Okay, so this is the, I think this will help you for your answer, but
Alright.
yeah, what is your question?
But how do you relate that to the column itself? Because as you saw, yeah, what I did initially was the 20%, and then down was the 3%. Like, how are you like, able to predict live during the column itself that maybe now is a good time to increase the polarity? Oh no, not yet, not right now.
Oh, so
yeah, it's always confusing.
as I already explained you before, so
Yeah.
if you think after checking all kinds of solvent and TLC,
Yeah.
when you kind of think like you have this kind of impurity and you're running the solvent and you see like maybe with the hexane like longer time hexane and you saw that it is coming out but your compound is not, so just run those out, wash those out, and once like you will get those fractions and then do the TLC with your crude material, okay? And when you see your crude material is here and you suppose you do couple of spot here, so you are getting these maybe make more spot, okay? These and these two spot are not showing up here. That means it was your last spot. Suppose it was your last spot just before your compound. So these two spot you are getting, but next two spot is nothing.
So
Okay?
it's out.
So that means this part is out.
Yeah.
Then just but if you have something else there also, then do not immediately increase a lot of polarity.
Oh, yeah.
Just then start adding more polar solvent. Like maybe if you are running 0%, then start 1% or 2%. Okay, because while you're running with hexane only, remember that those spots are moving. That doesn't mean that spot is not moving. That also could move.
So ideally, you do start off with 0%.
Yeah, start with this 0%,
Yeah.
but I would say it is not common for all kind of compounds.
Yeah.
That's why I said just study the crude when it is a new reaction. Study the crude with different
Solvents.
solvent system, run the TLC, check that, and try to understand, get the idea what is going on there. Once you know how to do that, how to handle this purification, and once you do it, then if you do the next time, then you don't need to do all those preliminary TLC things or like study things. Then you can always do the same way or similar way because you already will know that in that time. Okay.
So with the column, it's partially kind of a guess and check game, right? But
Yes.
but with the knowledge of the TLC already.
Yes.
Oh, okay.
And also like remember the functional group in your compound.
Right.
If you have the hydroxyl group, like especially if you have like suppose phenolic hydroxyl group in your compound.
I do.
That is problematic.
Yeah.
Like with the silica. Okay. If you have any kind of like alkene type compound or group, that is problematic in the silica. If you have triple bonded compound, not all time, maximum time. So those also have like a problem in the
And when you say problem, you mean
in
if
the
you
column.
Do, like,
Yeah,
if you do
that-
like a 2D TLC, it's gonna
yes, 2D TLC may give you some kind of
Weird
primary
angles.
idea.
Yeah,
Okay.
okay.
Because they can be like polymerized or like they can do something with the double bond, triple bond, which thing can be forming something weird thing.
Yeah.
Okay, or like if you have the amine NH2, it will stuck in the silica.
Oh, yeah.
Or NH can stuck in the silica. In that case, sometimes some people use little bit or like 1% triethylamine in the mobile phase so that the silica get like kind of basic,
Right, yeah.
basic,
Yeah.
and then they can do the column nicely.
with the amine, yeah.
Or sometimes it can be good for like alumina packing. Like if you do alumina having the NH2 or like NH type compound, whatever the like things.
Yeah.
So this NH type compound will be easier to
Yeah.
purify with the alumina. So a couple of things you need to remember.
Yeah.
Okay.
Cool. Thank you.
Uh,
Fun.
Did you get answer?
Yeah.
Okay.
All right. Peace out. Subscribe.